Konnichiwa, students. Today we're going to talk about applications of proportions. This is great because we start talking about things that you see in real life, like trees and poles and shadows. And there's a very, very important thing that you should always do before the math. I'll call it the prep work. Why? Because it's all the work you have to do before doing the actual math problem. And for that, you need to use logic, and you need to make sure that everything that you do is correct and it makes sense to you. So the idea here is we have a tree and we have a pole, and they're both casting shadows. So let's read through the problem, and then we'll kind of do our prep work. A tree of height h cast a 2.9 meter shadow, and at the same time a 2.4 meter pole cast a 1.3 meter shadow. So any idea why at the same time is so important? Well, this is kind of the prep work. In order to make sure your measurements, like the 2.9 and the 1.3 meter shadow, are correct and logical, you have to do this measurement when the sun is in the same position. This will allow you to have measurements that are actually, or the heights and the shadows that are actually proportional to each other, okay? So that's where that prep work comes into play. You need to make sure that is correct. Now, let's take a look at this. How can we think about this? Well, we can think about the height. I'm going to write that down. The height in what? Height in meters. And we can also think about the shadow's length in meters. So that's a good thing. We're going to be comparing meters to meters. And we'll start by thinking about the tree. We don't know the height, so we'll just put an h variable. And we do know the length of the shadow, though, and that is 2.9. Should I write shadow correct? There we go. Now, in this case, because it's the same time and the sun's in the same position, we can make a proportion and compare it to the pole. And the height of the pole, we do know, it's 2.4 meters, and the shadow is a length of 1.3 meters. So this will actually help us do what? It'll help us solve for the height of the tree. So when we did our prep work, we made sure we took all of our measurements at the exact same time. So we are going to actually take a look at a second example and solve this one. So if these two triangles are proportional, they're just telling it to you, what is x? So we're going to try to solve for the variable. Now in this case, our prep work is going to come in. We need to make sure that we're comparing the same sides. So where we have our variable, we want to use the same side on the other triangle. And then here we have our distance of 3 and our distance of 21. So when we set this up, we're going to set it up proportionally. So x over 3 equals 14 over 21. So you can see we put, I guess, the green values, okay? That length, both of them are the numerators, and the yellow lengths are our denominators. So that's very important. That's the prep work. So now you can do what? You can do your cross multiplication. In this case, we'll get 21x is equal to 14 times 3 is 42. Now, the only step we need now is to get x by itself, so divide both sides by 21, and we are left with the answer 2. And there we go. That's how you apply proportions. Let's take a look at another example. We're going to try to find a way to find the missing side lengths x and y of these two pentagons, which are 5-sided shapes. So we have our pentagons. We can see that the missing sides here are x and y, and we want to figure them out. Since these two shapes are proportional, we have to do our prep work by making sure we know what sides are proportional to what sides. And to do that, I'm going to focus on this right angle, this 90-degree angle. So what I'm going to do is I'm going to focus on this point, and it'll be the same point on the other figure. I'm going to call this figure 1, this is going to call this figure 2, just so we can use a name for it. And what you can hopefully see with this one, if we rotate this figure, well, that point would still be here, but what would happen is when we rotated it, we would end up getting the side to kind of look exactly the same as it does in figure 1 for figure 2. So let's keep that in mind. So how do we find the side on figure 2 that's proportional to this side on figure 1? Well, that idea of rotating, and if we took this point and rotated it, well, yes, it would end up being exactly proportional in the same position. So you can see these two sides are proportional. It's a little bit tough, but that's the prep work that you need to do to make sure the problem is going to be right. Now, from there, though, it gets a lot easier. So the side that's shooting off from here, from this point, would be this. It's going to be the exact same thing on this. So those should be proportional. And just to continue on from here, if we kept going up on figure 1, that would be the same idea on figure 2. Okay? So let's stop with that, and then we'll try to get into our proportion. I'm going to just erase this. So anytime you write a proportion, you are going to have the numerator and denominator, right? From, let's say, one figure, it's going to be the top and bottom. It's going to be this over this, but it's all going to come from this one figure. That's very, very important. So to get started, let's just do this. All right? We want to know, let's say, side y. So I'm going to write for figure 1, side y, and that's going to be equal. Well, what is that going to be equal to on figure 2? It's going to be equal to 14. So that's the tricky part. You're not putting y over 14. No, 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 no. Everything from on this equation, on this left side, is going to come from figure 1. Everything in the equation on the right side is going to come from figure 2. Okay? Hopefully that makes sense. So now we need to find a side on figure 1 and figure 2 that we can put numbers in here. And let me see, what can we do? Well, maybe if we continue on here, we get this, and then we'll continue on here. Hopefully what you can see, this is great. There is a measurement on both of these figures. So that's what I'll do. For figure 1, I'll have 15 and proportional to 10 on figure 2. And there we go. We have created our proportion. And we can just solve for our variable y, and it's great. How do we do that? Well, we're going to use cross multiplication. So let's go ahead and do that. 10 times y is just 10y. 15 times 14 is 210. And now, of course, we just have to divide both sides by 10, and that will get us our answer. So y equals 21. So there we go. You just really have to take your time when you are setting up the proportion, especially when you have shapes. Make sure you know what side kind of proportional to the other shape side. Now, let's finish this thing off. We still have to solve for an x. You can kind of reverse the side that you have the figure on in your proportion. Because we want to solve for x, we'll put figure 2 on the left. That might make life a little easier. Figure 1 on the right. So here is the blue. It is proportional to figure 1, side length of 9. And let's just use the numbers that we already know. So here, remember, we're always going to put the numbers from one figure all together in one fraction. So we'll put the 10 over here, and we'll put the 15 over here. So how do we solve for the variable? We can use our cross multiplication. So we get x times 15, or 15x, equals 10 times 9 is 90. Just divide both sides, and we will get our answer. So in this case, 90 divided by 15, of course, is 6. And there we go. We have our answer. We are done.